All right, in this video, we're going over questions 54, 55, and 56. Number 54 says, a fair coin is tossed 2 times in succession, right? The set of equally likely outcomes is the set of HH, HT, TH, and TT, H meaning heads, T meaning tails. Find the probability of getting the same outcome on each toss. So 54 is a basic probability question. The probability of same outcome, which equals to the number of items, number of outcomes that has the same outcome, divided by the number of possible outcomes. Now, looking at number 54, there are a total of 4 possible outcomes. And out of those 4 possible outcomes, 2 of them have the same outcomes, which is HH and TT. So the probability of having the same outcome when you toss 2 coins is 2/4, which equals to 1/2. So I'm now going to skip the middle part and get straight to the answer. Number 55 says, if you flip a coin 3 times, then the possible outcomes are the following. So I'm going to put a set bracket around it, and I'm going to put commas in the middle of each element. What is the probability of getting at least 1 head? So the probability of getting at least 1 head. First, we need to understand what the word at least 1 means. The words at least 1 together means 1 or more. I'll say at least 1. That means 1 or more heads. There are 8 possible outcomes for number 55, so that's our denominator. And the options that have 1 or more head is going to be the first 7 outcomes. The only one that does not qualify is the last one, because the option of tails, tails, tails has no heads. So that is eliminated. So that's going to be 7 out of 8. And 7/8 cannot be reduced, so you leave it as it is. Number 56. Ooh, a tricky one. A fair coin is tossed 5 times. What is the probability of getting exactly 4 heads? So there is 2 ways to go about this problem. One way is known as the binomial probability formula, but we don't teach binomial probability anymore, a part of Math 108, so that's okay. The other way is to write out the outcomes that has 4 heads, exactly 4 heads. So a fair coin is tossed 5 times. So let's first write the outcome. Outcomes for 4 heads when tossing 5 coins. Okay, so our event is going to be the set of H, 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 T. 4 heads, and then the last one is tails. Or I can reverse the order, where the first one is heads, and the rest of the tosses are tails. I can proceed to interchange. And then these are all the outcomes when you toss 5 coins and exactly 4 of the tosses are heads. So the cardinality of the event is 5. All we need is to find the sample space. So we found the event. Now we need to find the sample space. We do not want to try every possibility that we can get here when we toss 5 coins, because that can take us about a half an hour. But we're going to use the fundamental counting principle. Fundamental counting principle. And we're going to use it to find the number of outcomes we have when we toss a fair coin 5 times. So toss 1, toss 2, toss 3, toss 4, toss 5. When you toss a fair coin, there are 2 outcomes, heads or tails. So the first toss gives us 2 outcomes, heads or tails. As well as the second toss, there are also 2 outcomes, heads or tails. The third toss, also has 2 outcomes, heads or tails. So does the fourth, so does the fifth. Therefore, to find the number of ways, the number of outcomes we have when we toss a fair coin 5 times, we can multiply each of these events, rather each of these options for each of the events. So that's going to equal to 2 to the 5th power, which is 32. Therefore, the probability of exactly 4 heads with 5 tosses equals to 5 over 32. And once again, the answer may be a fraction. Let me see. The answer may be a decimal. I'm not sure. If the answer is a decimal, just divide 5 by 32, and then just round according to the question. All right. That is it for our coins. Hopefully you understood the concept and you enjoyed the video. I know 56 was a little bit more challenging, but having a challenge always makes people rise to the occasion. I'll catch you in the next one.